Hello everybody! So how do you create your own Azure DevOps extension? This is Stef from Samayas and welcome to my channel. So I've created a number of how-to videos about previous Azure DevOps extensions that I've created in the past. But how easy or hard is it to create one yourselves? Well, actually it's quite easy. First, you start fiddling with what you want to do as a PowerShell. Once you have your PowerShell up and running in a pipeline, you just need to create some context around it. So let's dig in. So now, let's start to create our Azure DevOps extension. For that, I'll be using Visual Studio, but you might just as well use Visual Studio Code, or you might just use a text editor. In this scenario, I'll just be using Visual Studio as a normal text editor. For that, I just open a folder instead of a project, since there's not really a project file available for this. And I just select my root directory, and as you can see, I've chosen to create one Git repo for that, and under that, currently, I have 5 specific tasks. The tasks I'll be talking about today is a .NET list package check. So in essence, you have a number of configuration files plus a PowerShell script, which is transformed by using a tfx command line tool to a v6. And then once you have the v6, you can upload it to your local Azure DevOps server or to the Azure DevOps Marketplace, so that other people can install it locally or in Azure DevOps Online. And so, the most important file in the project is the vss-extension file. The vss-extension file is the whole that glues your extension together. So first of all, you have some plumbing, you have a manifest version, you have the ID, which will be the ID of your package and needs to be unique. You have the publisher, in my scenario it's Samayas. You have a version, which I've hard-coded to 1.0.0, but every time you upload a new package, that version needs to be incremented, because the system refuses to re-upload 1.0.0. In my scenario, I have a build and release pipeline, and my build pipeline has an extension that automatically updates that version after each build. If you don't have that, you need to manually modify at each check-in if you want to test it. Next, I have a readable name, .NET list package check. I have description, then I have the fact whether or not my package is public or not. I have the categorization. In this scenario, I'm creating an Azure DevOps pipeline extension, and I'm targeting Microsoft Visual Studio. I specify an icon for my extension, and if you come on the extension page, you can see here that I have currently 4 extensions published, and that I'm using for each of my extension my company logo as an icon. Some use a specific icon for each extensions, others don't. So here, in my scenario, I have a company logo for my extension, but once you add the task to pipeline, there's a different logo. And then next, I have the files, which is the files I absolutely want to have included in my v6. First, I have the path to my PowerShell directory, and then next, I clearly specified each of the PNG images I want to include. The contribution section specifies which type of v6 this extension will be. Here, I'll be working specifically on a task extension, but you have a number of other possibilities. You can have a hub extension, you can have a menu extension, you can have a work item extension, etc. Here, it's configured to be a task extension. And then next, I have a content next to the files I've already specified. And first, I include an overview MD and a license MD. Now, if you want to, you can also include a privacy page and a Q&A page. I did not choose to do that. And as you can see here, I have my overview page, which is the overview MD I've included. I also have the possibility to click on license. And if I go to license, and my license page is a standard MIT license. And then finally, you have a default Q&A page, if you didn't provide any, where everybody who has some questions can ask some questions directly to you. And of course, we have the tags. And based on the tags and based on what people will enter in the search bar, your extension might pop up or not. And a nice feature is the branding. And this branding color specified here aligns with the branding of my logo. So the banner is nicely aligned with the logo I've uploaded. The next file we have is the package.json. So why does this have a package.json file? Well, in essence, this is a standard node project, and our TFX is converting this project to v6. We have the standard default node settings, we have a name, we have a version, description, a main, a script, keywords, author, license, and our dependencies. And the dependencies here are important. And in my scenario, I need this extension to be able to access what is needed from the Azure DevOps SDK. Next, I have a simple build command line where I call the tfx extension, where I call the tfx command line just to test if my extension is working. The next block is our home, and we've already briefly seen we have our overview MD, which is a physical MD file which is shown. As you can see, I have images included, and all those images are in the home image subdirectory. And if you go back to the VS extension, if I don't explicitly define those files, well, the images won't be shown on my MD file in my extension. And of course I have my license file, and that's it. And then finally, we have the plumbing. And for that, I created a PowerShell directory since I only have one task in my extension. However, in the past, I've created another extension which is called replacing files. And in there, instead of having a PowerShell directory, I have two subdirectories which look exactly the same, but with a different script. And so this extension, when being added, has two tasks. The first is replacing files between text, and the second is replacing files text by text. And so, depending on what you choose, instead of having specified my files PowerShell, I just specify the two subdirectories of my two PowerShell directories. So you can freely choose the directory name as long as your directory name corresponds with the file directory which you've included. For those who have been paying attention, in my PowerShell directory there's a task.json which defines my specific task. However, in my VSS extension, nowhere is the task.json referenced, which means that behind the hood, once Azure DevOps receives an extension, it will automatically look itself for task.jsons based on the file specified. Now if we go to task.json, here we have the plumbing which defines the task we'll be using. Let's first go to the bottom. So our task.json references directly our created PowerShell directory, which is .NET list packages check.ps1. And so here we specified in the current directory .NET list packages check.ps1. I'm not using any argument, and my working directory is my build source directory. If we go again to the top, of course, just like the VSS extension, we have a number of prerequisites. We have an ID, and this time the ID needs to be unique GUID. We have a name, which is just a technical name. We have a friendly name, which is the name of a task that will be shown. We have a description. We have a help down marker reference. We have again a category, which I've identified as utilities. We have again the author, and we have some version. And here, as you can see, version is having an issue because I have a major 1, I have a minor 1, and I have a string which is called build patch version. And that's something which I tweak the moment I install. And so in essence, for your package to be working correctly, we need a tool somewhere to first update this version, and then next to update this version. The next is called visibility, and this task will be shown under the build category, and the minimum agent version is the agent under which this will be supported. Every time there's a new Azure DevOps version, the agent is augmented. If you really create a task that is only supported with the latest version, you need to align. As far as I can tell, 1.83.0 is the agent that I will be supporting. And the instance name format is a name that out of the box will be shown once you add your task. And here I've included a parameter so that automatically that name is modified depending on the choices of the task. And then next we have groups and we have input. You might have a task which doesn't require any input and just works on a source directory. In that scenario, you don't need any groups or any inputs. However, in my scenario, I explicitly chose to have two sub-blocks. One, the scope of this task, and then two, the types of scan it executes. It allows me to open or close it. And so this groups allows us to specify for each of the variables to which group that input variable will be available. We might specify a group or we might just not. And if we don't specify a group, well, the variable will just be displayed under display name the moment you define it. Now if you have a look at the inputs, well, first I created an input of type radio. I gave it a name. I gave it a type. It has a label. It has a default value. It has help markdown, which is text message. It specifies whether or not it's required and the number of options for a radio button. And so as you can see, we have a radio button which shows either solution or a specific project. And so as we can see here, we have the label, choose the type of coverage, we have solution or specify project. If I click on the little I have the markdown, which specifies more text. Choose between solution coverage or specific project. Easy, right? Next, I have a second field, which is just a string, which is called parameter project directory. Again, it has a label. It has a default value, which is empty. It has again a help markdown. In this scenario, it is required false. It is again grouped in the group scope coverage, but as you can see, it's not present here. And why is it not present? Because I specified a visibility rule that my parameter type of coverage needs to be of type project. So only when I choose my radio button that I want a specific project will this text box be shown. And so now, if I switch from solution to specific project, suddenly I have my text box which shows up. I have the text, I have my markdown, and my text box works. So next, I have a second radio button of type scan, and now I have three options: vulnerable, deprecated, or outdated. And as you can see, it's grouped under scan type. I have again some markdown, and then under first parameter type of scan radio button, I have a second radio button, parameter type of outdated. And that one, visibility rule, is only visible when the parameter type of scan is outdated. So here, it's hidden. When I click on outdated, suddenly I have a second radio button where I can choose between all versions, highest minor, highest patch. As you can see, the second radio button is also not required. And then finally, I have an enable transitive check, which is a checkbox, which you can see here underneath. And here the visibility rule is a little bit more complicated. Either the parameter type of scan is not outdated, or if it is outdated, only when a parameter type of outdated is in all versions. And so now, if I click on highest minor or highest patch, it's gone. If I click again on deprecated, it's back. If I click on outdated, all versions, it's back. And so with some very easy logic, we're able to easily create a UI and options we can pass down along the script. Now if we dig into the script, say that first we created a script that was working without parameters, well, it's quite easy. We just need to call get vsts input, and we need to specify the name of the parameter name, and we put it in a variable. And then afterwards, that variable can be used down the line to make some decisions. Do I want to scan on vulnerable, on outdated, or on deprecated? If I'm of type outdated, then I can add whether or not it's a highest minor or a highest patch. And so this way, we just import each of our variables into our PowerShell. And so, with some tweaks, we were able to have a working Azure DevOps task. Now let's have a look at the build pipeline that I've created for building Azure DevOps extensions. As you can see, the build pipeline is pretty empty and everything is delegated to a task group. Since I have multiple build pipelines building multiple Azure DevOps extensions. My task group has three variables. I have project build number as a variable, I have project version number as a variable, and I have my root manifest folder. In essence, the extension that I want to build. If I go and have a look at my variables, I have my project build number, which is 10, and I have my project prefix number, which is 1.0. And in essence, if I concatenate both together, I have a project version number of 1.0.10. Now if I have a look at my task version, I have a number of subtasks. The first action I undertake, I call a replace in files, and I go to the task.json and I look for the build patch version. And this is the variable which gives an error which is coded in the task.json. And so in essence, this task searches in the source directory root manifest folder, which is my .NET list. It searches for task.json, it searches for build patch version, and it replaces it by project build number, which in this scenario will be 10. Next, I have a second replace, which is looking into the vss-extension.json, and it's searching hard-coded for version 1.0.0, and it's replacing it by project version number, which in this scenario will be 1.0.10. And as you can see, in my vss-extension.json, I've hard-coded 1.0.0. And by executing those two actions, I'm sure that my task.json and VSS extension always have the right and the latest version. The next action is not required, but is a first step into publishing the source code of this extension to Git. And so I copy everything to a Artifactory directory, Git source, and then next I publish it as an artifact attached to this build. Next, I have a node CLI, which in essence prepares a node and retrieves tfx-cli on the build machine. And then the action, which is important, is the package extension, and that one will be calling tfx-cli with a number of parameters in essence to create the v6. And so passes the root manifest folder, which is the extension I want to build, passes the version, and it builds a v6. And the next step looks for the v6 which has been built and transfers it to the artifact's release directory. And then once it's transferred, I have a publish artifact which publishes my artifact to the release. And then finally, my update build version number is responsible for updating the variable project build number for the next one. That means that on each successful build, this variable will receive +1 and I'll be ready for the next build. Now if we have a look at an individual build, I have two published artifacts, and if you go into detail, the first git source is a complete source of this extension, and the second one is a v6 which will be used to release. And if I have a look in detail, I'm replacing my build patch version by 9, I'm replacing 100 by 109, I'm copying over some files, I'm publishing an artifact, I'm preparing node, and I'm building my extension, I'm copying the artifact, and I'm publishing it. Next step is, before that you're able to publish something on the Azure DevOps marketplace, is that you need to create an account. And so here you have an option to build your own. I have already created it, so I can't re-show the creation process, but I can show you the screen. And so once you're signed in, you have an overview of all of the packages which are there, the version number of the packages, how those packages are reviewed, the number of downloads, etc. You can brand yourself, give some extra information, and you have a number of checks whether or not your package has a privacy page, has a license page, and has support. Now if you want to automate your release, you need a PAT or personal access token. And at first glance, that is something you would be looking for in the marketplace. However, nothing is here. Instead, you need to log in to dev.azure.com, and there you need to access the personal access token, and from there you can create a new token where you need to specify what it can do. In this scenario, I open up all scopes, and we go to extensions, and we give it read and manage. We go to marketplace, we select acquire and publish, and then we give it a token name, we give an expiration date, and that's the way to create a token. And the latest step after the build is to create a release. First, you need to add an artifact to your release pipeline, and there you go to the build pipeline, you add your artifact from the build pipeline, and you choose the latest or a specific version should you need to, but in general, on a normal release pipeline, we always choose the latest. And then, depending on how easy or how complex you want your release pipeline, you enable continuous deployment. And in my scenario, I have two publishes. I have a publish internal and I have a publish external. My publish internal publishes my v6 to my internal Azure DevOps server, and my publish external publishes it to the Azure Marketplace. So let's first have a look at my publish internal, and here again I'm using a task group since I have more than one release. And if I go into manage of my publish internal, I again use node CLI to be sure that my release machine has the tfx-cli. The next step, I call a task publish extension, connect to my local TFS server, Azure DevOps, I specify the v6 and I override the version. And once I have published it, I install it. I add a second task, install extension. Again, I connect to my internal TFS server and the same v6 I install. And that completes my install for my internal Azure DevOps server. Now let's have a look at my external publish. Again, I have a task group, and here again, it's more or less the same. I first call my use node CLI to be sure that my build machine has tfx-cli. Then again, I call publish extension, and this time I specify I want to publish to the Visual Studio Marketplace, and here I can manage my current extension. If you're new here, you need to create a new connection, and you need to enter first a name for your connection and the path which you've previously created in previous step. And once that's there, you have your Visual Studio Marketplace, and there again you can specify the v6 file and it'll publish it to the marketplace. And the latest step is a share extension task. And in here you can publish something to the marketplace and only provide it for a number of users, in essence to do some beta testing. And by specifying a variable here, for each of those releases you could specify a number of users which will have access to your new extension, and as long as you specify share with, that extension will be private and will only be accessible to those users and not to everybody, which is an option. And it's something which I play with is that for my internal publish, there's no filter. I publish automatically. However, for publishing to the marketplace, I don't want to automatically publish it. And so here I configure a rule that I need to give an approval on a release. That means that as long as I have not explicitly approved the publish external, it won't be published. And this completes our automated releases. As you can see, it's easier than you might have imagined, with the right plumbing in place, of course. If you guys enjoy this content, please give it a thumbs up, subscribe to this channel and hit the bell sign, or leave a comment down below.